Hello everyone. In this video, we'll take a look at double exponential smoothing, also called as trend adjusted forecasting, trend adjusted exponential smoothing, or it is also called as Holt's method. Okay, so we are given 10 periods of demand data, and our task is to forecast the demand for the periods 11, 12, and 13. Now, trend adjusted exponential smoothing requires two components. First is a level component, and another is a trend component. Now, the trend does not have any initial value given in the question. So we need to find some initial value of trend. We assume that we are observing the trend over 3 months. Unless it is specifically mentioned in the question, by default, we assume that one season is 3 months or one group of intervals for which we will observe the trend is 3 months. That is what we'll assume on our own. Okay. So for uh, period 1, the value is 500. And for period 2, so basically we are saying three intervals, right? So there is month 1 and month 2. Between them there is one month or one period or one interval, right? Then month 2 to month 3 is another interval, and month 3 to month 4 is the third interval, right? So we are trying to calculate the trend averaged over these three intervals. What is the trend basically? How steeply does the value change, right? So what is the difference between the value at month 1 and month 2 and month 3 and month 4? So overall, to calculate the trend, what we will do is we'll observe the value at the month 4, that is 528, and we'll observe the value at month 1 or period 1, that is 500, and we'll find the difference, which is 28. We will divide it by 3, not by 4, because there are only 3 intervals between them, right? So therefore 28 divided by 3 is 9.33. So that is our initial estimate of the trend. Initial trend is estimated as 9.33. Now, to calculate initial forecast for period 5, we need an initial estimate of level and initial estimate of trend. So level plus trend gives forecast. This is the backbone of this particular method, that is double exponential smoothing. What is the backbone? Level plus trend is the forecast. Okay. So for the initial forecast, we will assume that the value at month 4 is our initial forecast. Sorry, is our initial level. Okay. So initial trend is 9.33, and we will assume that the initial level is 528, and therefore our starting value of the trend adjusted forecast for period 5 is 537.33, and henceforth trend adjusted forecast, which we are writing as in short as TAF. So TAF in time period T is going to be the S value, that is the smoothed level value in the previous period, that is ST minus 1, and along with it we add the predicted trend value T predicted at the time period T minus 1. That is, we had the estimate for S4 and we had the estimate for T4, and we added them to get TAF of 5. Okay, that is forecast. Now the level update has the form TAF plus alpha actual value minus the forecast value. This is very similar to what you write in single exponential smoothing. This is very similar to what you calculate in single exponential smoothing. Single exponential smoothing only works with level. Here we are working with level as well as trend. Okay. So to update the level, Here we say ST, that is the smoothed value at level at time period t is equal to the trend adjusted forecast at time period t plus alpha, which is the smoothing constant, times AT, that is the actual value at time period t, minus trend adjusted forecast at time period t. Okay, so this means that we correct the forecast by a fraction alpha of the error, because actual minus forecast, right? AT minus TAF of t, this gives us the error, and we take a fraction of that error, which is dictated by the smoothing constant, that is alpha, and we add it to the forecast. So we adjust the forecast by adding a fraction of the error, that is our smoothed value. We also update the trend. For updating the trend, we we find out how much the level has changed beyond what the previous trend predicted. So how can we find out how much the level has changed? For that, you will say ST, that is the smoothed level at the time period t, minus ST minus 1, smoothed level at the time period t minus 1. That is the change in the level. And when we calculated the trend earlier, what did 9.33 mean? 9.33 meant that on an average, if we compare 500 and 528, which is after 3 intervals, on an average, we can say that every interval sees an increase of 9.33. Similarly, here, T of t minus 1 means that is the prediction of trend. Ki S T of t minus, S of t minus 1, that is the smoothed value at t minus 1, smoothed value of level at the time t minus 1, plus the trend at the time t minus 1 should give you the smoothed value at the time period t. But that is not what actually happens, right? So there is some error, there is some difference. So we are multiplying that difference by beta. Just like in case of the previous equation, when we updated the level, we took a fraction alpha of that error. Similarly, here we are taking a fraction beta of the actual trend, which is ST minus 1, minus the predicted trend, which is T of t minus 1. And then we add that to T of t minus 1. That is our prediction or update value for the trend. Okay, so thus we have the formulas for the trend adjusted forecast, the level update, and the trend update. Okay, now let's calculate the value for period 5. The actual value here is 540. The trend adjusted forecast for period 5 was 528 plus 9.33, that is 537.33. Okay, now actual value 540 is slightly higher than our forecast. So the error is 540 minus 537.33, which is 2.67. It's a positive error. Now we update the level using alpha equal to 0.3. Okay, so S5 will be 537.33 plus zero point 0.3 times 540 minus 537.33, which is 2.67. So this gives us as 538.13. This is the smoothed value at time interval 5. So the trend estimate still remains 9.33 for this step because this is our first iteration. And the trend formula needs both the current and previous S values. So the new trend is still assumed to be 9.33. Once we will calculate S6, then we can calculate S6 minus S5. That will be our, predict that's like the predicted trend versus actual trend can be done when we actually calculate S6. Okay, so S6 minus S5 will be our ideal trend value or observed trend value, and T5 will be this 9.33, and then we'll see how much is that different. That will be multiplied by beta, and that will be trend update step. Let's move on. period 5 calculation is done. For period 6, trend adjusted forecast is you add S5 and T5. So S5 is 538.13, T5 is 9.33. You add them, you get 547.46. So this is your trend adjusted forecast. Okay, but the actual value for period 6 is 542, which is lower than the forecast this time. So the error will be 542 minus 547.46, which is minus 5.46. So we update the level using alpha equal to 0.3. So S6 will be 547.46 plus 0.3 times minus 5.46. So this will give us 545.82. So that is the level update step. We have calculated trend adjusted forecast for time period 6. We have calculated the level update for time period 6. Now we update the trend. For trend update, the T5 value is 9.33. Now we'll see what is the observed change in the S values or smooth values, which will be the observed trend. So observed trend is 547.46 minus 537.33, and the trend that we had predicted, or TT minus 1, was 9.33. That difference is multiplied by beta, which is 0.2. So 9.33 plus 0.2 times this difference. This gives us 9.49. So the slight adjustment is in the upward direction in the trend. That means underlying slope is still positive, but it is showing small fluctuations in the positive direction. It is moving ahead, okay, increasing. For time period 7, again we'll calculate the trend adjusted forecast of the 7th time period. So TAF of T, that is TAF of 7, will be equal to S6 plus T6. So it will be 545.82 plus 9.49, which is 555.31. Okay, now the actual value is 558, which is higher than the forecast. So again it gives us a positive error. Positive error means that the model underestimated the demand, and so the level will be adjusted upwards. So we update the level S7 as 555.31, which is the trend adjusted forecast, plus 0.3 times 558 minus 555.31, actual minus forecast multiplied by the fraction smoothing constant. So that gives us 556.12. And the prediction in trend, now the change in trend, basically update in trend, will be the trend that we had estimated in the previous iteration, that is T6, was 9.49. What did we observe instead? 555.31 minus 547.46. Okay, and this is the observed minus 9.49. This difference has to be multiplied by the smoothing constant of 0.2, which we add to 9.49. So we can say that the trend has moved slightly downwards this time, because although the actual value increased, the increase was not as strong as compared to the earlier periods. So therefore the trend value will still be positive, but it will be decreased from 9.49 to 9.16. Now for time period 8, the trend adjusted forecast is S7 plus T7, again, which is 565.28. Next we update the level. So S8 will be S. So basically level has to be updated depending on whether the prediction was higher or lower than the actual value. Actual value is 550, which is significantly lower than the forecast. So therefore it results in a large negative error, 15, right? Large negative error, meaning the model's predicted upward movement was not mm, like the predicted upward movement was too strong, was not correct, it was too strong, right? So instead of the trend adjusted forecast level being 565.28, we will adjust the trend adjusted forecast, or we'll smooth it basically. We'll smooth it to 565.28 plus zero point 0.3 times the difference between 550 and 565.28, which will be a negative number and adjusted by the smoothing constant of 0.3 alpha, and that will give us the value 560.7. Then we update the trend, and trend is updated as T8 is equal to 9.16 plus zero point 0.2, that is 565.28 minus 555.31 minus 9.16. So observed trend minus 9.16 multiplied by the smoothing constant, which is zero point 0.2. So even though the actual value was lower, the trend increases slightly because the level S8 is still higher than the level S7, maintaining a mild positive slope, right? So therefore, we can say that the trend has increased. So now the trend value is 9.32. Now for time period 9, trend adjusted forecast at time period 9 is S8 plus T8, which is 570.02, and actual value is exactly 570, almost perfectly matching the forecast. So this results in an extremely small error, practically zero, meaning our smooth values are now well aligned with the observed data. So level update will be almost no change, right? So 570.01. And for trend update, the trend decreases this time significantly because the increase between S8 and S9 is smaller than what the previous trend predicted. So therefore, the trend value will now decrease to 8.41. For the time period 10, trend adjusted forecast is S9 plus T9, which is 570.01 plus 8.41, which is 578.42. The actual value 575 is slightly lower, giving a small negative error. We update level one final time. Okay, so now 578, which is the forecast value plus zero point 0.3 times, that is alpha times 575 minus 578.42. So this gives us 577.40, and next we will update the trend, which is 8.41 plus zero point 0.2 times 578.42 minus 570.02 minus 8.41. So it is almost exactly the same. The trend remains the same. So this tells us that the model believes the slope has stabilized now. Now that we have S10 and T10, forecasting future periods is very straightforward. Okay, so F11 will simply be S10 plus 10, T10. This is 585.81. Okay, and for period 12, it will be S10 plus 2 times T10. So 577.40 plus 2 times the trend value. And for the period 13, it will be S10 plus 3 times 8.41, that is 602.63. Okay, so once we finish the actual values, we don't update the level and trend anymore. We can update level and trend only till we have the actual values available with us, and that we have only till time period 10. For time period 11, 12 and 13, we simply carry forward the same S10, basically the same smoothed level and trend values, and simply say that this is our stabilized trend value that we'll use. So S10 plus T10 is F11, S10 plus twice T10 is T12, and S10 plus thrice T10 is the forecast for the period 13. That's it. If you have any questions, any doubts, do post them in the comments below. Thank you.